So when I left you before, I was talking about solidified groups and how I nest my geometric sets. In this case, I've got two surfaces I will solidify. I have a disk and I have a support. So I have what I call solidified groups of geometric sets. I've got a disk, and then I've got a disk surface, disk reference, which doesn't have anything in it. And then I've got a disk wireframe here that has wireframe, at least a pointed surface. So I'm going to end up solidifying this revolved surface. As far as the support, I've got an extruded surface and a fill. I've joined them together, and I've got one final joined surface that I will solidify into its own body as well. So I've got two solidified groups. So I like to do my solidifying in the part design workbench. So I'm going to jump over to part design. Going to create a body. I'm going to call this body disk, and I call this name matching. You notice how I've got disk. That's going to be the solidify of this revolved surface, and then notice the geometric set is disk, so disk, and then disk surface, disk reference, disk wireframe, and also the axis systems have disk axis system as well. So let's do the solidified. So I'm going to insert surface space feature, thick surface. This I'm going to make 5 millimeters, and I'll take the default direction for that. Cool. And I don't like these. I call these G0 corners. That's a sharp edge, of course. The topological edge. I call them a G0 edge because it has G0 continuity across here. So I'm going to throw in a tritangent fillet there to round that up. In order to see that better, I'm going to hide my disk geometric set. And I try to tell my students, never hide this final surface that you solidified, leave it visible. If you want to get rid of and not see that surface, just hide the geometric set. So I'm going to come over, I'm going to do a tritangent fillet, and the faces to fillet will be the bottom and the top, and the face to remove will be there. It's a nice little rounded end of my disc. Now, that's all I'm going to do on that. So next will be the support. So I'm going to insert a body. I'm going to call it support, and again, recognize the name matching. My philosophy is, you should be able to turn this over to somebody else and they can know what you're doing, especially when a student turns it into me to be graded. I can look, and if they're following best practices, I can easily replicate what they've tried to do. So I've got a body called disk and a new body called support. This is the active working location, so I can solidify this, and I'm going to solidify this in as a thick surface. And this one, I'm going to go with a 2. Thinking about doing a 3, but I'm going to just go with a 2 instead, millimeter. So I wanted this to be a different thickness, just to add to the problem, if you will. If not, I could have, if they were all the same thickness, I could have probably have done this easily as one solidified group, but I wanted to add a little bit of a challenge. So I'm done with this surface, so I can hide that surface. And there's what I have as far as two bodies, both unrelated to each other, independent of each other as far as the order of regeneration. This is not a topological edge here. You can see it's not really showing as an edge. So again, two independent surfaces. So also I want to pattern this. So for the sake of, I knew what the model was going to be, so I decided to do the pattern in the part design workbench versus a surface. I think it adds a little bit of strength to the model. So I'm going to add a pattern to this. It's just going to be a full crown, 4 instances, rotational pattern. So so let's do a complete crown, and then we'll do 4 of these. And I don't even have to select the geometry because I'm doing everything before it in the current body. And my reference direction is going to be the z-axis in the current axis system. And there's my 4. Again, still independent of the disk. So this is where it gets interesting. The way I will create my bodies. I add several layers of bodies, and it's probably overkill, but I like the flexibility of it. And again, this is my best practice. In the real world, I doubt anybody else uses this best practice, but it is what I teach my students, and so I expect them to follow this best practice. So I'm going to create a new body, and I'm going to call this finished part. And this is going to be a body that's underneath the part body. Boolean added in. So I'm going to add this into the part body. So I'm going to make the part body the defined working location. There's several ways to do this, but this is the procedure I follow. I'll make this the defined work location. I'll pre-select the finished part, and I'll go insert Boolean operation, add. Okay, and it puts it under. Okay, so that's a sub-level under part body. Now I'm going to do another body, and I'm going to call this add body. Many of you will probably think this is overkill, but I find the flexibility very useful. So I've got an add body. I'm going to put this under finished part, so make that to the final work location. Again, right click, define a work object, pre-select, insert, Boolean operation, add. Okay. And then here will be where I put in my solidified body, or bodies that have solidifies in them. So I've already got the 2 of them out here already created. So I want to make add body my current working location. I want to pre-select disk. I'm going to put disk in first and support second, because I'm going to union trim in support. If I was just adding both in, I can do them both at the same time, or you can do them both at the same time and then change the add to a union trim. So, but I prefer to do it this way. So on define a work object location here, pre-select disk, insert Boolean operation, add. Again, nothing changed topologically, but that's getting ready to happen here next. So next I'm going to pre-select support. I'm going to go insert the Boolean operation. This time it's going to be a union trim. So what I'm going to, in this case, I'm only going to pick faces to remove. And I want to remove these top flat surfaces on my pattern. There should be 4 surfaces to remove. And I'm going to try a couple of different things, but that's the first thing I'm going to do. I'm going to select there, and then I'll hit OK, and we can see what happens. And then I'll add to it. So I'll pick those 4 top surfaces. I'm going to hit OK just so we can see the effect. So you can see what's happening there under the bottom. Now, that's not exactly what I was looking for. I mean, I knew what I was going to get, but I want to see inside the support. So I'm going to go back to my union trim, and I'm going to do a surfaces to keep. I'm going to pick this outer surface, and when I did that, notice it gave me the hole. So I've done this a couple of different ways, and I will show you. Instead of doing faces to keep, see if I can get this out of there. Instead of doing faces to keep, I could have also done faces to remove and picked inside of here. It just depends on how you think your model is going to be a little more robust, but that works as well. So either way, I like the first way the best, but I'm going to keep it this way. So I've got pretty much what I'm looking for. I don't like these, of course, with product design, I don't really like these G's. This is, again, like I said, I call this a G0 edge, that sharp edge. I'm not sure I made that term up or not, but I probably didn't. I probably got it from somebody and forgot who I got it from, but I call that a G0 edge, as opposed to this, which I would call a tangent edge. I would call this a tangent edge because it comes tangent here, tritangent fillet. I call this a G0, or you can call it a sharp edge. So I want to round those off a bit. And probably want to do it on this side as well. And if you were thinking about doing an edge fillet here, I could pick about any face here or here. It's going to propagate over these tangent edges and hit all of the G0 edges. I'm going to give that a shot. So I'm going to put this under the ad body. It's about as deep as I can get it on the tree. It would work under finished part. It would actually work under part body. But this is as deep as I can put it, and I like to put it as deep as possible. So I'm going to put my fillet here. If the design is suitable to do this, I can pick here. I've got tangent propagation turned on, so it propagates and finds those G0 edges. And let me just see what a 5mm fillet would do if it's not too big. I want to tap that down to 3mm. And let's see what it looks like. So I've got the rounded edges there. Of course, you can imagine trying to get this out of a mold, but I'm not trying to manufacture this. I'm just showing examples. But keep in mind, though, that when you make something, you've got to be able to manufacture this, or in this case, mold this. And I'd probably have to do a little bit more work on this to be able to get this in and out of a mold, but it is an example anyway. So, but the main thing I wanted to show you here was how I set up my geometric sets and how I set up my bodies. So notice how when we come back to this, I've got two solidify groups. One is going to be the support, and the other one is going to be the disc. And I've integrated them together with bodies and union trims. And the way I've got my tree, again, these are all my best practices. They're not necessarily anybody else's best practices, but these best practices for how to integrate this is how I teach my students as far as organization inside of CATIA. And I love using the geometric sets, and I love keeping them organized by the wireframe entities and references, but most especially the surfaces subgeometric sets is where I'm very particular with my students. In the end, they can only have one visible surface. Everything else has been hidden due to operations on surfaces to end up with one surface that you can solidify. So notice I've got one visible surface here, and up here I've only got one visible surface. So that's one thing I look for in my students, is making sure that they've done the correct operations to end up with that final surface. So I hope this helps, but this is an example of how I integrate bodies with surfaces inside of CATIA. Thanks.